Hello and welcome to the first tutorial series on HAROS, the High Assurance ROS framework. In this video we will be going through the first batch of suggested exercises, more specifically exercises focusing on internal code quality. Let's start by navigating to the proper directory in the repository. And here you can find a short introduction to what is internal code quality, as well as a preparation section before the proper exercises. So let's start by following these preparation steps. And as we can see, the first step is basically running a simple HAROS command that we just have to copy and paste to a terminal within the Docker container that we provide in this repository. I'm going to start the Docker container now, and it starts in its internal workspace directory. The first thing is to run the catkin script so that it builds the workspace within the container, and then, of course, as in every other ROS system, you will source the workspace before moving on. We move into the repositories directory within the container, and now we copy the suggested command and paste it onto the terminal to run a simple HAROS analysis. Once it completes, we switch back to the web browser, open a new tab on localhost 8080, and it should start the HAROS Visualizer webpage. You can see that the initial number of reported issues is fairly large, and the next goal is going to be to filter out some of these issues so that we focus on what matters for the following exercises. We're going to start by editing the project file that we are passing as input in order to add a few extra parameters that are going to filter out or ignore some of the reported issues. As we can see here, we are ignoring everything related to formatting or copyright notices. In addition, we are going to blacklist or ignore some of the plugins that are already available in order to further focus on a specific subset of the issues that we want to fix in this tutorial. So let's shut down the previous visualization server and run the modified command, switch back again to the web browser and refresh the page to load the new results. We can see that the total number of issues now is much smaller. And if we navigate to the issues panel, we can see that we can now properly navigate this page without too much clutter. Alright, so moving on to the first exercise. This exercise will be focusing on the Fictibot random controller package. And we can see that there is an uninitialized variable in this source code. And this is a problem because their values can vary from one program execution to another. Our first task is to locate this variable and assign it an initial value. So let's switch back to the HAROS tab, and we can see that HAROS already reports the location in which this variable is accessed. So let's navigate to this location in the source code. Going back to the random controller package and to the pointed file. We now scroll through to the pointed line, and here we can see the obstacle variable being used. So if we scroll up, we can see its initial declaration and a number of if cases that assign it a value. But as we can see, there is no general else case. So there is a possibility that this variable will not have an initial value explicitly assigned. So let's just assign it a value of false initially, and then the other cases cover the instances in which it has to be true. That's basically it. Let's run the analysis again, repeating the same command. Again, go back to the web page, refresh it. We can see that it has one less issue. If we navigate now to the reported issues for the package, we no longer see that issue. And this is exactly the steps that are written out here in the solution. Moving on to exercise 2, we now are focusing on the drivers package. And the current problem is that there are two variables that are not at their smallest scope. These variables are the delta v and the limit variables. This is not really an issue, but it can make the code more confusing. So let's locate these variables and move them down to the proper scope. We have to locate the motor manager file and line 73. So let's get to it. And there we go. Here is the declaration of the two variables. So now if we scroll down, you can see that at the bottom of this huge block of this if statement, there is only one more statement before the function ends, and then these variables are not used at all at the level they are declared. We can easily find the two uses of these variables within this if statement, so we can simply delete the initial declaration and move it to within the block. We can save the file, shut down the previous analysis and repeat the command again. Go back to the web server, refresh the page, and again the number of issues goes down. If we navigate to the proper page, we can see that these issues are no longer reported, so we have successfully fixed the issues. We can now move on to the final exercise, again in the Fictibot drivers package, and this time the problem is that the spin function is both too long and too complex. So we are going to tackle two issues at once in the same function. Here we go, we can confirm that these issues are indeed reported in our instance of the analysis. And we can see that they both point to the same location, which presumably is the location in which this function is. Our task is to locate this function and refactor it this time to make it shorter and more simple. If we open the file, we can see that indeed this is a fairly large function. It has many if statements. It's quite confusing at a first glance to understand what's going on. But we can visually identify some structures here. There are two main if blocks within this function that are basically independent from one another, and maybe we can move them to their own functions that we will then call within the spin function. So here we have a block that's basically manipulating linear velocities, and then another almost duplicated block which is manipulating angular velocities. They are independent from one another. So let's do exactly that. Let's make them their own functions so that we can reduce some of the if statements within the main spin function. In order to add a new function, we're going to declare them in the header file. Let's call them update linear velocity and update angular velocity. And now we add their implementations to the CPP file. Just going to copy and paste for convenience, change the names. And now we can safely cut this first block and call update linear velocity instead. Let's paste the block down into its new location. And one function done. Now let's repeat the same thing for the second function, the update angular velocity. We must not forget that now we have to redeclare these variables that were previously available. And we should be done. The function is now much shorter and much more straightforward to understand, especially this section. So let's close the files and rerun the Catkin script just to make sure things compile. Everything seems to be working as expected. So let's get back to the repository directory and rerun the Hyros command again. Let's refresh the web browser. You can see again the number of issues going down, and the issues that we previously had are no longer reported. We have successfully fixed the spin function. As we can see, the suggested instructions are exactly the steps that we just performed. And with this, we have reached the end of the first batch of exercises on internal code quality. So stay tuned for the next one.